Hello everyone, in this particular video, let's see some basic interview questions related to arrays. Again, I'm saying it's very basic questions. We'll go deep into it in the later videos. We'll see how to achieve the first question, sum of all elements of an array. For that, I'll take out an example. Let's say array equal to 10, 20, 30, 40. We have an array. What we need to return? We need to return answer as 10 plus 20 plus 30 plus 40, which is equal to 100. To solve this, what are the approaches that we have? We have a direct approach to solve this. We just need to loop through the array and we need to store every time the sum. For that, what I need to do, I'll take out a variable sum and it is initialized to 0 and we'll loop through the array. As we all know, array index start with 0, still a controversial statement. But anyways, I is equal to 0. So array of I, which means array of 0 is equal to 10. Right now sum is equal to 0 and we have a array of I is equal to 10. So sum plus array of I which is equal to 10. Now the sum is equal to 10 and then I is equal to 1 again. Array of 1 is equal to 20 now. Sum is equal to 10. Array of I is equal to 20. 10 plus 20 which is equal to 30. Right now sum is equal to 30. Then again I is equal to 2. Array of 2 is equal to 30. Now sum is equal to 30 and array of I is equal to 30. 30 plus 30 is equal to 60. And last I is equal to 3. Array of 3 is equal to 40. Sum is equal to 60. 60 plus 40 which is equal to 100. And now sum is equal to 100. We got the answer. But my another question, will this work for negative numbers? Let's see. Now my array of elements is equal to minus 10, minus 20, minus 30. So what we need to return? We need to return the total sum which is minus 10, minus 20, minus 30 which is equal to minus 60. We need to return minus 60. For that we'll take the same approach. We'll initialize sum as 0 and now I is equal to 0. Array of 0 is equal to minus 10. 0 minus 10 which is equal to minus 10. Now sum is equal to minus 10 and 20 which I is equal to 1. Array of 1 is equal to minus 20. Now sum is equal to minus 10 minus 20 which is equal to minus 30. Right now sum is equal to minus 30 and then I is equal to 2. So array of 2 is equal to minus 30. Sum now minus 30 and array of I is equal to minus 30 which is equal to minus 60. We got the solution. So this is the approach which works for all conditions. Now let's see how to code it up. So for the first question, I'll take public int return or get some int array. The very first thing what we can do is we can take we need to calculate the size of an array. For that int n equal to array dot length and later we need to loop through the array. Before that we need to declare a variable int sum and let's initialize to 0. We need to loop int I equal to 0, I less than n, I plus plus and sum is equal to sum plus array of I. At the last we need to return sum. That's it. This is a code for the first question. Okay, let's see the next question. The largest element of an array. For that one, I'll take out an example array. A is equal to 12, 7, 13, 8. In this example, I can say the largest element is 13. As a human, we can easily say that, but how can you represent it to the code? How can you explain your approach to the interviewer? That's the main thing. Now let's see how to solve this. Just like a previous question, we are taking a variable. Now this time it's maxi or anything. But this time we are not assigning 0 to it. Why? Because for example, in an array, all the elements are represented with minus or negative elements. Then if we can take out max equal to 0, it will give you wrong answer. For that reason, we are taking maxi equal to the least number in the integer. It's integer dot min. Again, it's language specific. The syntax may vary. You can check out that. And now let's start the approach. Loop through the array, and we need to compare every time with the maxi element. Initially, I is equal to 0. Now array of 0 is equal to 12. We can see 12 is greater than the int dot min. We can replace int dot min with the 12 as it is a greater one. Next thing, I is equal to 1. Now array of 1 is equal to 7. You can compare 7 with 12, but 7 is not greater than 12. So you can skip that. And now I is equal to 2. Array of 2 is equal to 13. Now 13 is larger than the 12. You can replace 12 with 13 right now. And the max is equal to 13. And I is equal to 3. Array of 3 is equal to 8. 8 is not greater than 13, so you can ignore it. Now the maxi element which is stored is 13. We got the answer. Will this works for negative condition as well? Yes. Let's see that as well. Array is equal to minus 12 to minus 3, or I would say minus 2, minus 12, minus 2, minus 3. Yeah, that's it for now. And just like previous one, let me take max equal to int dot min, and if I equal to 0, then array of 0 is equal to minus 12. Max a is int dot min and minus 12, so minus 12 is greater than somewhat int dot min, so we can replace this with minus 12. Now I is equal to 1 and array of 1 is equal to minus 2. Minus 2 is greater than minus 12. Yes. So now it converted to minus 2. Now the max is equal to minus 2. If I is equal to 2, array of 2 is equal to minus 3. And minus 3 is not greater than minus 2. In negative numbers, the smallest one is the greatest one. And right now the maxi contains minus 2. Hence, this is valid for both the conditions. Now let's code it up. Now let's code the solution. Public int get max int array. First thing is we need to calculate the size of an array. Int n equal to array dot length. And next thing is we need to assign a variable int maxi, and let's initialize that to integer dot min value. Let's start the looping. Int I equal to 0, I less than n, I plus plus. Every time the loop runs, we need to compare. So maxi equal to math dot max maxi with array of I. Whichever is the largest one, it is going to store in maxi. And at last we can return maxi. So this is a code for finding maximum element in an array. Now let's see the third question, the second largest element in an array. It's a bit interesting question. Let's see how can we solve that. You can see an array 12, 7, 8 and 18. If you ask me what is the second largest element, I can say the second largest element is 12. But how can you find that? How can you explain your solution to the interviewer? Uh, the very first thing that comes to my mind, the brute force approach is to sort the array. If we sort the array, the resulting array will be 7, 8, 12 and 18. And we can simply return array of n minus 2. That will give us the answer. The main problem with the solution is it is using order of n log n for sorting itself. How can we avoid that? Now let's see. We have a lot of solutions to optimize, but I'll tell you the most optimal solution where we can do everything in a single pass. To achieve that, we need to take out two variables, the largest and second largest. And initially I'm assigning both to minimum. Now, when I is equal to 0, array of 0 is equal to 12. 12 is greater than minimum. But before that, I would like to tell you one point. Whenever there is a change in L, first of all, we need to copy the L value to SL and then we can change the L. We'll see the example as well. And if I is equal to 0, array of 0 is equal to 12. So 12 is greater than L. But before that, we need to copy L value to the SL. In this condition, both are same. We don't need to copy anything. We can simply replace this with 12. Next, if I is equal to 1, array of 1 is equal to 7. In this condition, 7 is not greater than 12. So we can skip it. If I is equal to 2, array of 2 is equal to 8. In this condition, same. 8 is not greater than 12. We can skip that as well. And if I is equal to 3, array of 3 is equal to 18. In this condition, 18 is greater than 12. We can replace that. But before that, what we need to do, we need to copy the largest into second largest. And now second largest becomes 12, largest becomes 18. And we can simply return the second largest one at the end of the function. That's what we can get the answer. Okay, let's see the another case. For example, if the array does not contain any second largest element, then what will happen? For example, if the array is equal to 10, 10, 10. In this particular array, we don't find any second largest element. Then we can return minus 1. In most of the interviewers say just return minus 1. But how to achieve this? Will our solution work for this condition? Let's see. Let's take out again two variables, largest equal to min, second largest equal to min. Okay. Now I is equal to 0, array of 0 is equal to 10. 10 is greater than min, so we can replace 10. I is equal to 1, array of 1 is equal to 10. Now you can see 10 is not greater than 10. Now we cannot do anything. I is equal to 2, array of 2 is equal to 10. Same, 10 is not greater than 10. At the end of the day, SL remains min and L remains 10. Whenever at the end of the day, SL still remains min, we can return minus 1 from there itself. I think you got the approach. Now let's code it up so that you can get a better clarity on it. Yeah, now let's start coding the third solution. Public int get second largest int array. The very first thing we need to calculate the size of an array, array dot length. The second thing we need to declare two variables, largest equal to integer dot min value and int second largest equal to integer dot min value. Now for int I equal to 0, I less than n, I plus plus. The very first condition, if there is any change in L, then we need to first copy the L value into SL. That's what we'll write here. If array of I is greater than largest, we can say S largest equal to largest first and then largest equal to array of I. This is the first condition, and there is second condition as well. If the element is lesser than the largest and higher than the second largest, then we can replace that easily. So if array of I is smaller than the largest and array of I is greater than the second largest, then we can replace second largest with array of I. At the end of the day, if S largest is still integer dot min value, we can return minus 1, or else if that's not the case, we can return S largest. That's it. It will work for all conditions as well. Now let's see the last question, how to find the missing element in an array. Let me take out an example. array is equal to 1, 5, 3, 2. What is the missing element? The missing element is 4. Okay, let me take out another example. 6, 1, 4, 2, 3. What is the missing element? The missing element is 5. So it starts from 1 to n. We need to find out what is the missing element. That is the question. How can you solve this? Even we have a lot of approaches. We'll pick up the best one and the easiest one. Let me write the array again. 6, 4, 1, 3, 2. Okay. Now, I think you have read a lot of mathematics in your school days. We can recollect that once now. Do you remember what is the formula for finding the first n natural numbers? It's n into n plus 1 by 2, right? So we are going to use the same formula and let's see how can we implement this. First, I'll take out something like sum of n natural numbers and I will take another one, sum is equal to. Initially, sum is equal to 0 and sum of n is equal to also 0 and sum of n, which means sum of n natural numbers. Here n represents not the size of an array, n represents the last element, I mean the highest element in an array. Okay, now 6 into 6 plus 1 by 2, 2 and 3, sorry, 2 and 6, 3, 3 into 6 plus 1, that is 21. So we get number as 21. Okay, now s of n natural numbers is 21. Then what is sum represent? We need to calculate the total sum in the array. If we calculate the total sum, then it would be 6 plus 10, 6 plus 4, 10, 10 plus 1, 11, 11 plus 3, 14, 14 plus 2, 16. If we minus or if you remove sum from sum of n natural numbers, then we'll get the answer. Sum of n minus sum, which means 21 minus 16, 5. So missing number is 5. This is the approach. We'll take out another example. Let's see if it works or not. Array is equal to 2, 3, 4. Now let's test. Sum of n natural numbers is 4 into 4 plus 1 by 2. 5, 10. So sum of n natural numbers is 10. I'll clean up. Sum of n is equal to 10. And what is the sum of current array? 2 into 2 plus 3, 5, 5 plus 4, 9. So sum is equal to 9. So sum of n minus sum is equal to 10 minus 9, that equal to 1. So 1 is a missing number. This is how we can solve this particular question. Now let's see how can we code it up. Now let's code the solution for the fourth question. Find the missing element in an array. So what we're gonna do, public int find missing element int array. So now int n equal to array dot length n plus 1 and we need to take out int sum of n is equal to n into n plus 1 by 2 and int sum is equal to 0 for int I equal to 0, I less than array dot length I plus plus sum is equal to sum plus array of I, and at the last we can say return sum of n minus sum. That's it. That's it for this missing unnatural numbers, missing number in a unnatural number array.